Our next topic is going to be memory, which is probably one of my favorite topics in psychology. And I want you to think about for a moment what life would be like without memory. If we didn't have memories, we wouldn't be able to rely on our past. We wouldn't be able to learn. And also, most importantly, we wouldn't be able to know who we are, because our sense of self, our sense of identity comes from memories that we have about our tendencies, our preferences, and so on. So without memory, you really wouldn't know who you are as an individual. And you wouldn't also have any idea of the future, because in order to create an idea of future, you need to have memory. Just to give you an example, if you need to buy milk on your way home today, you project that idea onto the future, and then on your way home you're going to have to remember to do whatever it is that you're supposed to do. So even the future is dependent upon memory. So memory can be defined as the process by which information is encoded, stored, and then retrieved. You want to be able to get the information. Encoded comes from a word, putting into a code. Right? So you put into a code that you can process further. Then you store that information away, and then at some later point you're going to bring that information out and retrieve it. Now, encoding is analogous to, or can be considered to be like turning a sensation into a perception. So you take something that's meaningless and you transform it into a psychological formula that you can represent mentally, something that you can work with, something that you can then store away. And we can encode visual information represented as pictures. You can only imagine a picture is in your mind's eye. You can all process information auditorily, right, represented as sounds. And we can store away information semantically, which means by meaning. Right? So you can all, for example, process the information, visual information of an apple, the auditory processing of the word apple, and what the word apple means. Once we have encoded, once we have our hold on to the information, we can maintain it over time by storing it away. And typically the most simple way of storing information is through rehearsal. So we rehearse information, repeat information over and over until that information is sent to a more permanent space where we can hold on to that information for a longer period of time, sometimes even a lifetime. We can use maintenance rehearsal, which is to hold on to the information for shorter period of time. Like, for example, if someone gives you a phone number that you need to dial and they say it to you out loud, you're going to rehearse it in your head until you dial it, and then that information is gone. So that type of rehearsal is maintenance rehearsal, because you're just maintaining that information. You're not really doing anything that would promote a long-lasting memory. A longer lasting type of rehearsal is elaborative rehearsal. Elaboration means that you do something with the information, that you take that information and you relate that information with some other information that you might already know, or you construct some sort of a network of association between that information and other information. Like, for example, I'm sure most of you are aware of the fact that in order for you to remember information better, you can relate it to something that has to do with yourself, so some personal experience, some examples that you can relate to. So that is why it's useful to imagine and think about and discuss examples of particular topics and concepts and ideas that are discussed in class. Right? When you talk about, like in a previous chapter, we discussed learning, and we talked about classical conditioning, and again, you can more easily remember what, for example, classical conditioning is if you can remember how your dog reacts when you show them a leash, right? And they get excited, and that is because of classical conditioning. So you see how an example can really help you retain information. Meta memory, by the way, is the knowledge of how your memory system works. So the more you know about how your particular memory system works, the better you'll be able to utilize it. As we discussed before, you need to know how something works in order to modify, in order to change it, in order to make it better. And again, meta memory is memory for the functioning of your own memory system. And finally, we have retrieval, right? So encoding, put information into a code. Like, you can imagine encoding being like you have your hands on the information. Unless you encode, you cannot do anything with the information. So if let's say someone is telling you some information that you didn't hear properly, you're not going to be able to do anything with it because you never encoded it in the first place. So you need to be able to capture the information somehow and put them into a mental code. Then storage, and finally retrieval. Retrieval involves locating the information. Let's assume that the information is stored away somewhere in your mind. You need to find it. You need to locate that information and return it to consciousness, your conscious mind, your active mind, right? When you're consciously processing the information. And retrieval, for the most part, relies on what are appropriately called retrieval cues. So they're cues that help you find the information. It will be like, let's say you can't remember a name and someone gives you the first letter of that name, or whether the name is a long name or a short name. So all of those information will allow you to more easily locate the information. And for example, a type of memory that is tested by identification is based on retrieval cues. So you're more easily able to identify information if you're provided some cues. Like, for example, in a multiple choice question, in a multiple choice question you have a lot of retrieval cues. As a matter of fact, the ultimate retrieval cues, because one of the answers is there in front of you. Right? So that's that's why recognition is much easier than recall. You can much more easily recognize some material because, again, that's the ultimate retrieval cues is right there in front of you. Now, one of the most used model of memory, or theory of memory, if you will, is the Atkinson and Shiffrin model. And it's based on time. It has to do with how long the information how long ago the information was presented to us. And immediately after presentation of the information, the model suggests that we process it at the sensory level. From a sensory level, it moves on to a short-term memory, which is also known as working memory. After that, it moves on to long-term memory, where it is stored forever. And so again, the stages determine whether we are holding on to and for how long information is stored in that particular system. And here is a schematic representation of the Atkinson and Shiffrin model. We have an input, which is a sensory input. It could be an image, it could be a sound, it could be some the sound related to some meaningful information. But well, the model suggests that first we process that information at the sensory level, in sensory memory. Unless we process it properly, we're gonna lose that information. Some of the information in sensory memory is then captured and moves on to short-term memory, which is a active memory, or consciousness, if you want to relate it to the previous chapter. So consciously we process some of the sensory information that are available to us, and we can rehearse it. So we can, as I mentioned before, for example, rehearse a phone number, consciously repeating those numbers to ourselves over and over. And unless we rehearse it properly, the information is going to be lost. And the more we rehearse, the more likely it is that that information will move on to the next stage, which is long-term memory. Now, in long-term memory, the information is held forever. And at some point, whenever we need that information, we can look into it and bring that information out back into our conscious short-term memory, right? So you weren't thinking about what you had for breakfast this morning, but as soon as I asked you, what did you have for breakfast this morning, you could look into your long-term memory, take that piece of information and bring it into your consciousness, and now you'll be consciously aware of what you had for breakfast. There's a question as to whether or not we ever lose information in long-term memory. Some researchers believe that once information is in long-term memory, it's going to be there forever. And the only problem as to why we might not be able to remember the information is because we can't find it. Right? So the problem locating the information. Information is there, in long-term memory, we just can't find it anymore, and it might be lost. Right. So as I mentioned before, sensory memory is this first stage of memory, and it holds impression for a very short period of time. In the case of visual sensory memory, between a quarter of a second and a half a second. And we perceive what is known as a memory trace. Right? So if you can imagine, for example, the visual memory is the easiest one to discuss because we can all experience that and talk about easily. For example, as I was saying, if you can imagine someone moving around in the middle of the night, a lighted object, right? Something that emits light when it's dark, you will perceive a trace of that light moving. Right? You don't perceive the light as individual location where that light is placed, but rather you'll see almost like a line of that light moving, like when you walk, when you drive on a highway, for example, you might perceive some lights in the distance as being continuous rather than having individual points of light. And this is the memory trace. And it's meaningless, right? So it doesn't have any meaning at this stage. It's analogous to sensation. So it doesn't have any meaning yet. It's just our senses basically are activated by stimuli, and our senses holds on to that information for a very short period of time, and unless we move it on to our conscious memory, what we call short-term memory, that information is going to be lost. So we have different types of sensory memory. Basically, virtually every sense that we possess, every sensation that we possess is a sensory memory. So we have iconic memory, where mental representation of visual stimuli, like the icon of visual. Echoic memory is a mental representation of sound, and they last longer than icon, as I mentioned before, 250 to 500 milliseconds for iconic memory. For echoic, we're talking about in a range of 1 to 2 seconds. So we hear basically information that were presented to us a couple of seconds ago. So we still can capture and process auditory information for a couple of seconds. If we wait, too long after that, the information is gone. If we are interested in some of the information presented in sensory memory, we're going to capture some of them and move them on to our conscious memory, which we call short-term memory, and we can then process that information and rehearse it and actively do something with it, connect it to other information, manipulate it, understand it. So it's where we actively do something with the material. And that's why short-term memory is also called working memory, because we are working with the material. We are doing something with the material. And again, rehearsal, if we rehearse a material, it sends information on to the next stage, which is long-term memory, where we can hold on to the information virtually indefinitely. We have memories of our childhood that we can remember. So think about how many years that have passed, and still we can still remember that information. Now, as a result of these memory processes, serial position effects come into place. Whenever we are presented with information in a series, we have the tendency to better recall, to have a better memory for the first and the last item in a series. It's called primacy, right? The ability to remember information in the beginning of a list, and recency, the ability to remember information better at the end. And that may be because we pay more attention to the first and last item, but also by looking at this Atkinson and Shiffrin model, because information that are presented in the beginning of a list is rehearsed more. We have more time to rehearse that material because it was presented first. So more time passes between presentation and recall, allowing for more rehearsal. On the other hand, we remember better the end of the list, what we call recency, because it's most fresh, is the freshest in our mind, is the last piece of information that was presented to us. Let's say the last word in a series of words that we have to remember. It was presented last, we're going to remember it better because it was just presented a few seconds ago. In short-term memory, we can also use a process known as chunking. So a mental process where we are taking information and we are grouping it together, and we are making it into a chunk. Now, some research showed that we can only hold a certain number of items in short-term memory, and we can hold 7 plus or minus 2 pieces of information at any given time. right? So 7 plus or minus 2, that is between 5 and 9, correct? So we can hold on to, in our active mind, between 5 and 9 pieces of information, an average of 7. It is not a coincidence that phone numbers are 7 digits. That comes from the fact that this research have shown that, normally, under normal circumstances, individual can hold on to those 7 items in their mind and rehearse them without having to write them down. However, chunking can also be used to decrease the number of items in a list. Let me give you an example. If, let's say, I'm trying to remember a list of numbers, right? And let's say it's 2, 5, 0, 8, 4. Right? That's five digits that you have to remember. However, as you have noticed, maybe some of you picked up on this, that 3 of the digits are 5, 0, and 8. Now 5, 0, and 8, 508 is the area code of this region of Massachusetts. Now if you think about 508 as the area code as opposed to 3 distinct digits, then you will process it as a single unit, and it will only take over one place in your short-term memory. So you see this idea of chunking, of grouping together pieces of information into units that require less mental space to process it. And of course, when you do that, you're also elaborating on the material, making not only easier for your short-term memory to process the information, but also making a longer lasting long-term memory, a stronger long-term memory for the information. How do we lose information in short-term memory? And the most typical way of losing information in short-term memory is interference, when other information interfere with whatever it is that we are trying to process. And so attention and distracting information interferes with the material that we are currently trying to process. And more specifically than that, information interfere the most if it is similar. So similar information is more likely to kick out other information from memory than different information. At least, when you're talking about short-term memory. Again, let me give you an example of this. Let's assume you are counting numbers. Let's say you're counting how much money you made in a whatever thing, in a sale that you have done, and you're there counting your money, 78, 79, 80, 81, 82. If someone wants to distract you, what they can do is that they can come over and start saying numbers. As soon as they start saying numbers, those numbers that they say are going to interfere very strongly with your counting ability, and very likely you're going to lose that count and you're going to have to start from the beginning. On the other hand, if someone comes over and as you're counting money and they say animal names, cat, dog, giraffe, elephant, that's not going to do anything to interfere with your task of counting. All right, so similar information interfere the most. And finally, the last stage in the Atkinson and Shiffrin model is long-term memory. Vast storehouse of information. There is no limit to the amount of information that can be held in long-term memory. As a matter of fact, the more information we put into long-term memory, probably the better our memory is, because we're going to make more connection. We'll be able to establish more relationship between among rather information that we are holding. And the more connections you make, the more easily you'll be able to get to that information via retrieval cues, right? And as I mentioned before, this long-term memory can last a lifetime. You can remember information from your childhood as if it was yesterday.